Good day, guys. This is your tutor engineer. Today we'll be doing an exam question on momentum and impulse. So let's start. Conservation of momentum, rather. It says what is meant by the isolated system in physics. That's the first question. So the isolated system is when there is no resultant force acting on it. So that would be the answer. There is zero resultant or net force acting on it. So let's continue with the following question. During the experiment, a rocket of unknown mass is mounted on a toy cart of mass 20 grams. The cart-rocket combination moves at a constant speed of 2.5 meters per second along the horizontal floor. At a certain instant, the rocket is fired horizontally in the direction of motion at a speed of 30 meters per second. So let's just pause a bit. So we have the cart, we have the rocket, they are moving at this speed. We're given the mass of the cart, that's 20 grams. They're moving together at a speed of 22.5 meters per second, and then they separate finally as the bullet moves at a speed of 30 meters per second. The cart is going to slow down by a certain velocity to 0.6 meters per second. So the first question here is 4.2. Use the relevant physics principle to explain why the firing of the rocket will slow down the cart. So as the rocket moves at 30 meters per second, it's going to push back the cart. So the cart will reduce the speed from initially 2.5 meters per second to 0.6. So that's how you're going to answer this question. The bullet will push back, or it will apply a force on the cart which is to the opposite direction, actually slowing it down. Now let's go to 4.3. 4.3 says calculate the mass of the rocket at the instant the rocket was fired from the toy cart. So we don't know the mass of the rocket, so let's call it mr initially and finally mr. The mass of the cart, remember, will remain 20 grams for initially and finally. The mass doesn't change for both objects. So we know the law of conservation of momentum. It's m1 v1 initial plus m2 v2 initial is equal to m1 v2 final plus m2 v2 final. In our case, we have got the rocket and the cart. So the cart, the mass of the cart, I'll call it mc, and so on. I'll use c and r for rocket and cart. So since they are both together here, they are moving at the same speed as a unit. The mass of the rocket and the cart, I can just call it m1, or I can just split it if I want as m1 and m2. So I will say mr for the rocket, that's moving at the same initial velocity. Let's call it vr initial plus mc v c initial is equal to mr vr final plus mc vc final. So the mr, that's the mass I'm interested in. Initially the rocket was moving at 2.5 meters per second in the positive direction. Remember, this direction we'll choose it as positive, so everything to the right is positive and vice versa, to the left it's negative. So that will be plus the mass of the cart, I know that is 20. It's also moving at the same speed, 2.5. That will be equal to the mass of the rocket that I don't know as yet. But finally the rocket will start moving at the final velocity. It's of 30 meters per second. So I'll multiply it by 30 here, plus the mass of the cart remains 20, but the mass of the cart final will be 0.6 meters per second. So from here it's just going to be simple stuff. This would be 2.5 times mr plus 20 times 2.5. What is it going to give me? It's going to give me a 50. And then here I'll have 30 times mr, and then 20 times 0.6 will give me a 12. So from here on, it will be very easy. I'll take 30 to the left. That means 2.5 mr will be joined by minus 30 mr. Here 12 minus 50. So 2.5 minus 30 is minus 27.5 mr. Then 12 minus 50 is minus 38. And divide by minus 27.5 minus 27.5 will give me the mass for the rocket. So the mass for rocket is 1.382 kilograms.